So here you may be given a question to determine the eigenvalues and eigenvectors associated with the matrix A equaling 2, 0, 1, -1, 4, -1, -1, 2, then 0. So how do we come up with the eigenvalues and eigenvectors? It's what we are going to look at. We shall write A equals 2, 0, 1, -1, 4, -1, -1, 2, 0 as our matrix. Hereby we know that when we are going to find the eigenvalues and the eigenvectors of a matrix, it is given like A minus lambda identity, which is equal to 0. So hereby, when we are given A minus lambda identity, it will be A, whereby our A is 2, 0, 1, -1, 4, -1, -1, 2, and 0. Then we subtract lambda identity, whereby lambda identity will be lambda into 1, 0, 0, 0, 1, 0, 0, 0, 1, which is equaling to 0. So from there, this is 2 minus lambda, then 0, 1, then -1, 2 minus lambda, then -1, then -1, 2, and 0. This one is equal to 0. Then from here, we shall have to find the determinant of the matrix given. Then we equate it to 0 to get the value of lambda. 2 minus lambda, then into this bracket, which is 4 minus lambda, then -1, 2, and 0. And from there, we shall have our minus 0. This one is a mistake. This one is minus lambda, because this, we have said it is A minus lambda identity, whereby this one is also minus lambda. Then we write, then we get 0, whereby 0 into, we close this column and this row. So from there it will be -1, -1. Then here it is also -1, negative lambda. Then we add, we get this, we add 1 into, we come up with, we close this and this, then we come with -1, -1, 4 minus lambda, then here we come with 2. And from there, here we shall have to multiply the determinant of this bracket, whereby it will be 2 minus lambda into 4 minus lambda times negative lambda, which is -4 lambda plus lambda squared. Then here it is minus 2 times -1, which is plus 2, into minus 0 into, of course this 0 we have to cancel out all of this one. You can even call it 0, it is useless because this is 0 times the bracket. Then we add 1 into, this is -2 times -1 times 2, which is -2. Then we subtract 4 negative lambda times -1, whereby we shall have to put a small bracket, which is -1 times this, which is -4, and then plus lambda. This one is equal to 0. Of course, all these are equaling to 0. So from there, then here we shall have to get 2 minus lambda into -4 plus lambda squared. This is -4 lambda and plus 2. Then this one is already 0. We shall have to add 1 into -2. Then of course this is negative. When we open up a bracket, it will be plus 4. Then minus minus lambda, which is equal to 0. When we multiply the brackets, then we shall have to come up with the equation, this one. From here, we shall have to assume for the values of lambda, whereby when we put lambda into this equation, we get 0. Whereby we can assume, like we say lambda, let lambda equal, let's say 1. So when we put 1 in this equation, we shall have to get a 0. Because here it is lambda, this one, or lambda, which is equal to 1. When we put it into this lambda, it will be negative 1, then plus 6. When we put lambda here, when lambda squared, because 1 squared is equal to 1, when we multiply it by 6, comes 6. Then we subtract 11 minus times, we say 11 times 1, which is 11, then plus 6. When we add up this one, what do we get? It means that lambda equals 1, or lambda minus 1 equal to 0. This one is a factor of this equation. Come up with negative lambda 3 plus 6 lambda squared minus 11 lambda plus 6. We shall have to get this lambda. We shall get lambda plus, so we shall get this equation divided by lambda minus 1. Then here we shall have to get this divided by this. We get lambda negative lambda squared. Then we multiply, you get lambda cubed. Get this one times this, get plus it is lambda, I'm sorry, it is lambda squared. Then when we subtract, we shall have to come up with 0. When we subtract here, it is 5 lambda squared. Then we bring this minus 11 lambda plus 6. So when we divide all this equation, we shall have to get our equation as negative lambda squared plus 5 lambda minus 6 as another equation. Then here we factorize out this one. When we factorize out this one, we shall have to come up with, we shall have to factorize this one, whereby it will be minus lambda squared. Then here the factors here, whereby we can add and get 5, it will be plus 2 lambda plus 3 lambda. When we add this one, we get 5 lambda minus 6. So when we multiply this, we shall get this 6. When we multiply 2 and 3. Then from there, we factorize out the common factors in this, or the common figures. Whereby it is minus lambda, we put it outside, we come up with lambda inside, then minus 2, because when we get this one times this, negative lambda times negative 2, we get positive 2 lambda. Then plus 3 into lambda minus 2. Remember, this one is equal to 0. Then from there, we shall have to connect the terms together, like the bracket, we take it, and then we get this minus plus 3 into lambda. So here, lambda will be equaling to 3 in this, then another lambda will be equaling to 2. So our eigenvalues are lambda equals 3, lambda equals 2. Then we have our lambda equals 1, this one here, this one here. We first solved, we first assumed this. Then these ones are eigenvalues. So from there, we shall have to look for the eigenvectors. How do we look for the eigenvectors? So for the eigenvectors, which will be, we shall first look for lambda equals 1. For lambda equals 1. So for lambda equals 1, we shall have to bring our matrix A, whereby our matrix A 2, 0, minus 1, negative 1, 2, negative 4, negative 1, negative 1, 2, and 0. So when we subtracted our lambda, whereby we had our lambda A minus lambda identity equals 0, we got the equation as minus lambda, here as minus lambda. I think you can remember it very well. So we shall have to get this one. We shall have to put here at our lambda, we shall have to put 1. When we get 2 minus 1, that one will be 1, 0, 1, get negative 1, 4 minus 1, this is 3, then negative 1, 2, and negative 1. This one equal to 0. So from there, we shall have to know that it is our A minus our lambda identity into x equaling to 0 when we are looking for the eigen lambda, whereby it will be A, which is a negative, which is 1, 0, 1, negative 1, 3, negative 1, negative 1, 2, and negative 1. So we put x1, x2, and x3. This one will be equaling to 0. So from there, we shall have to multiply this by column. So we shall get this one times this. So that is x1, this one times this, that is plus 0, plus this one times this, which is 1 times x3, which is x3 equaling to this 0. So from there, we shall have x1 plus x3 equaling to 0. This one is equation 1. Then we multiply all of these row by column. This is negative x1 plus 3x2 plus is minus x3 equaling to 0. This one is equation 2. This is equation 1. This is equation 2. Then here we shall have to get negative x1 by this, getting the third equation. Then from here we shall have to solve equation 1. How do we solve it? We shall have x1 plus x3 equal to 0. We shall take this one this side. We shall bring it this side, getting x1 equaling to negative x3. So here we shall have to say here there is a coefficient of 1. Here there is the coefficient of 1. This is negative 1. This is 1. So we shall have to get x1 equaling to negative 1. Then x3 is equal to 1. Then we shall have